Vapor absorption system. The vapor absorption cooling system comprises all the processes within the vapor compression cooling system like compression, condensation, expansion, and evaporation. Within the vapor absorption system, the refrigerant used is ammonia, water, or lithium bromide. The refrigerant gets condensed within the condenser and gets evaporated within the evaporator. The refrigerant produces a cooling effect within the evaporator and releases warmth to the atmosphere via the condenser. Difference between vapor compression system and vapor absorption system. The major difference between the two systems is that the method of the suction and compression of the refrigerant within the refrigeration cycle. Within the vapor compression system, the compressor sucks the refrigerant from the evaporator and compresses it to the high. The compressor also enables the flow of the refrigerant through the entire refrigeration cycle. Within the vapor absorption cycle, the method of suction and compression are administered by two different devices called the absorber and the generator. Thus the absorber and therefore the generator replaces the compressor within the vapor absorption cycle. The absorbent enables the flow of the refrigerant from the absorber to the generator by absorbing it. Another major difference between the vapor compression and vapor absorption cycle is that the method during which the energy input is given to the system. Within the vapor compression system, the energy input is given within the sort of the mechanical work from the electrical motor traveled by the electricity, but within the vapor absorption system, the energy input is given within the sort of the warmth. Components of vapor absorption system. 1. Condenser. Within the traditional condenser of the vapor compression cycle, the refrigerant enters the condenser at high and the temperature gets condensed. The condenser is of a water-cooled type. 2. Expansion valve. When the refrigerant passes through the expansion valve, its pressure and temperature reduce suddenly. This refrigerant, ammonia, then enters into the evaporator. 3. Evaporator. The refrigerant is very low and temperature enters the evaporator and produces the cooling effect. Within the vapor compression cycle, this refrigerant is sucked by the compressor, but within the vapor absorption cycle, this refrigerant flows to the absorber that acts as a suction, a part of the refrigeration cycle. 4. Absorber. The absorber consists of the weak solution of the refrigerant, ammonia, and absorbent, water. When ammonia from the evaporator enters the absorber, it's get absorbed by the absorbent, by which the pressure inside the absorber reduces further, resulting in more flow of the refrigerant from the evaporator to the absorber. At heat, water absorbs lesser ammonia, hence it's cooled by the external coolant to extend its ammonia absorption capacity. This is it for today's video. Let us know in the comment section which topic you want to see next. Before leaving, check the exclusive offers, link in the description below. And do not forget to hit the like and subscribe button. To find out more on the subject, continue watching the next video.